hello. Today we're going to check out the Make Noise O Control. So the O control / no control, a bit of an unfair thing to call it since it has lots of control, is Make Noise's first standalone sequencer. And while you may be familiar with the idea of step sequencers that have got modes where you push buttons and tell it to be in a certain state, No Control doesn't have that. Instead, you create different states by how you patch and self-patch the system. By patching it back in and of itself, you create different behaviors. So, for example, you can constrain the sequencer within a certain amount of steps, or make it ping-pong, or change direction, or jump around from step to step in different ways. Most interestingly, you can also have completely different timing per step if you use this as your master clock source, and it will make interesting swung clocks, or clocks that almost stop completely on one step and then blast through speedily on the next. So let's patch it up and see what it does. So we have 3 rows of knobs. The top is pitch, the middle is called strength, and the bottom is called time. Now that's because all 3 of those are designed to do interesting things to do with pitch, strength, and time, but of course they are also just analog control voltage outputs. These 3 outputs here correspond to the rows here. If you have the benefit of sight, you might be able to see that there is a sort of legending ring around the rows, and it's indicating the double ring here is this, the single white band is this, the single dim ring is here. So to patch this, what I'm going to do is I'm going to patch the pitch row output into the 1 volt per octave input of the no coast. I'm going to patch what is called a dynamic gate output here into the gate input of the no coast. When I do that, now the no control controls the coast. So suddenly there's something interesting happening here. No coast responds to gate volume or gate strength. So that if I turn these rows down, the no coast actually quietens itself corresponding to the voltage that are coming in. And I have a master control here to control the overall amount of gate strength that I'm plugging into it. Those of you who are familiar with analog gear will find this somewhat surprising if you didn't know that the no coast has a dynamic gate input, because most analog gear tends not to respond in this way. Either it triggers the whole voice because a certain volume of gate has been achieved, or it doesn't trigger it at all. It doesn't do all of the in-betweens, but what's cool is the no coast does. So when you pair this with the no coast, you get interesting velocity patterns. Now, if I don't have an analog synth that responds in that way, I can still make use of the dynamic gate output, because if you have it past sort of 9 o'clock per step, it doesn't trigger the gate at all. So in this way, by having the steps turned down or up fully, no matter what analog synth I have, I can explore interesting gate patterns by just turning down or up steps. And I can just feel this out intuitively. Now, there's another thing that this does. Do you see this cool flashing little light screen? This is the dynamic envelope output. And what that's doing is, instead of outputting a gate, which is just a thing that goes up and down, up and down, up and down, or in this case, at different levels, this is a dynamic contoured shaped output. So what I did is just fed it into the dynamic input. For those modular people, that's just the VCA that controls the overall volume of the no coast. And what we're hearing is a curved response that the no control is creating. Ooh. And if you're sharp-eared, you might start to question, like, how is it there's something else happening here? So the strength output is really clever. At low steps, it makes a little pluck. And then as I increase it, that pluck increases in length. And as I turn up the dial even more, we get a sustain portion on the pluck. And as I turn it up even more, you get more sustain. So it sort of goes through this like kind of range of responses, depending on how much I've turned this up. And it means that at lower steps, you get like little soft plucks, and at high, you get long, sort of like sustained little steps. And it makes for a very dynamic and expressive output. And it's very unusual that a step sequencer would create such an interesting envelope. That is not normal. I don't know many others that do that. So it's like a ready-made, like, fascinating, interesting, expressive control voltage to use as your VCA, your master VCA output control signal. And again, we have this knob here, which controls the overall amount of it. So I can use that as a performance control. So this bottom row is time. And time is that. I've got all of the knobs turned down, and I've got the attenuator here in the middle. If I start to turn them up, and I'll turn up the strength row so we get a slightly louder signal to hear. Suddenly the timing of our sequence changes. And what's really, really, really interesting is on the control, you can create a completely uniquely timed sequence. It is such a thing on analog step sequencers that they have rigid timing that never changes. And that roboticness, that's a musical goal, and I love that. But I must say, it doesn't mean a thing if it ain't got that swing. And with this, you're able to create with time and with patience, really interesting swung rhythms. And then you have a clock output. So you can then use that swung rhythm that the control is creating as your master clock, feed your drum machines from it, and create a much more human, dynamic performance. And we'll do that later in this vid. Nice. You can have lilting sequences that So down here we have this keyboard thing, this touch plate system. And of course, this is where things start to get really interesting. We've got pitch, strength, and time, so we can have these interesting steps. And then with this keyboardy thing, touch plate thing, we can then change the order, mess around, and interact with the melodies that we've made. The name of these things, this is the clock plate, which I use to start the clock. This is the direction, which if I push, I will change the direction of the sequence. And I can perform that. So this one here is called interrupt. An interrupt is really interesting. If I have the interrupt light on and I touch the plate, it will interrupt the sequence. I can play all the stages with their associated timing, pitch, and strength information. And it's interesting, you start to find like melodies within melodies. By just performing the notes you have chosen, you can create like new riffs from it. And it is important to point out, the pitches that you create with the pitch row do have to be very precisely tuned by your ear in order to be like within concert pitch, if that is your musical goal. It obviously also means that it inherently can create microtonal music where you're creating musical scales by ear yourself. And especially using interrupt is useful because you can repeat a stage. You have to tune your scale. And you would have to tune all your other gear to this. But it makes for a really interesting music making experience because it gets you out of old habits. So then we have all of this other stuff up here. Now, you saw me messing with direction, and there's a really cool little arrow that's telling you the sequencer is going which direction. There is also reset and stop. And these are fascinatingly interesting. With the no control, you get these two stacking cables. So the beauty of CV is that you can use the interesting control voltages you're making here to go and control any other parameter that you have a CV input for. But the beauty of the stacking cable is that I still have two outputs available. I can use either end, and I can also send that into another CV control. So I can control overtone as well, and I could continue this on the other end. And so, for example, I could do things like feed it into direction. So then, if a certain pitch is achieved, it will change direction for me. But actually, what is perhaps far more interesting is using gates to control these, because what these inputs are looking for is a really strong on and off to tell them to work. And every single one of these rows creates a gate when it is reached. So every time this is hitting here, it is sending a gate from these outputs. And that means you can patch this to change direction when it reaches a certain point. You can see it becomes like a sort of springy like rebound now. Boing, and it wraps around like on asteroids. Really cool. What is even cooler whilst I was showing you that these stacking cables can be used to split a signal and send it to multiple destinations, it's okay to use stacking cables to combine gates. Don't use them to combine voltages, but use them to combine gates. So for example, there's a gate being created here. If I plug this into here, now these two are the springers that bounce the sequence. And I can change that by repatching them into different... Aha! And what happened there, I patched it while the little playhead was inside, so now it's ping-ponging within this little range. And now interrupt allows me to jump the sequence around. So I can throw the little playhead outside that little range, or back in. So what you're going to see is this kind of like performance scenario emerging, where it's like I've set up the no control so that if I touch the plate within this row, then these things will happen, and if I then touch it outside of the row, then those things will happen. And then by just performing the interrupts, I am performing my sequence in a way that a sequence becomes something you don't just like program and stand back and admire, but that you are creating a set of conditions. You're almost building a sequencer and a sequence, and then it's up to you to finish it and perform it. See? It's really interesting sort of approaching a sequencer in that way. And there's more. There are more things that this can do. So the other things are reset and stop. And what that's going to do is literally reset the sequence or stop it when it receives a gate. But the reset is not a reset like you might know from other analog sequencers, where on a traditional analog step sequencer, a common thing is that when reset is applied, or gate is applied to reset, then the sequencer will just only reset to the first point. But that's not what this does. Reset resets to the last touched plate. And that is a very different thing and very interesting. So then if I patch this into reset, and I push the first plate, then we do get that trad analog behavior. We get a 4-step sequencer. But if I touch the second plate, 3 steps. That now is the plate it resets to. And then if I touch other plates, we get other behavior. It skips out these ones here. It runs right to here, runs along, and then plays from here. Because the direction is to the right. Wicked. So interesting, like, hard to predict sometimes. There's a really funny thing it says in the manual where it's like, the pitch row will create many voltages you want, and also many voltages you don't want. Like, there is a degree of experimentation and like interaction, but there's also a whole host of interesting surprises, as you can tell. So that's reset. Stop, by the way, stops the sequence. If I play the sequencer, it's obviously going to run and run and run and run and run. But if I patch the stop, and I'll use the last one, then it will stop the sequence at that point. Like that. finally, we've got these sort of golden outputs. And what these are, the golden gate one here, golden gate, that's good, is the, I don't know if that's actually what it's called, but that's what it has to be called now, is going to output a gate every time I touch a plate. So if I unpatch the dynamic gate output from the no coast, and I have it so that this golden gate is triggering the no coast, then I get keyboard behavior, so that every time I'm touching a plate, I'm getting a trigger. Sounds like it would be like really, really a pain in the bum to tune every note, but you kind of do it as this sort of passage, and I find it quite intuitive. Like, I just kind of hear the notes in relationship to each other, which is nice. You can't help but kind of create your own scale. Probably, a musicologist would be like, dude, you're literally always tuning it always within a certain scale, and that's like my built-in Mylar scale, but it is what it is. So what's nice here is we've got sustain. If I turn up the contour, we can get nice longer notes. And that's unique to the envelope generator that you're plugging it into. But what you want to know is that this is creating the gate that is held for as long as I'm holding the note down. Like that. But then there's this other thing, this like funky output, which you can actually see lighting up at certain times. So that is the pressure output. And perhaps pressure is a slightly misleading term. It's to do with the amount of your finger that is touching the plate. So if a tiny little bit of your finger is touching the plate, it doesn't light up so easily. But if more of your finger touches the plate, then it does. And it's just a control voltage that we can use to control the timbral or pitch or anything that you want to control. So then if I plug it into the multiply output, there's a wahoo. See, so pressure is really interesting. And if you're now like adding up all of these features in your head, you might ask, if I'm going to be playing a clocked sequence, if I push the keyboard, I'm going to interrupt. And that's right, but interrupt can be turned off. So if I turn off interrupt, when I touch the plate, it will not jump the sequence around, but it will let me play with pressure. So I can play with pressure, and if I turn interrupt on, then I can play with interrupt and pressure. I think the only other thing that I haven't mentioned is these inputs for strength and time. Initially, I thought these let you control the attenuation of strength and time, but actually they're external CV inputs. They allow you to use things like LFOs and other interesting control voltages that you're creating to control time and strength. And that, I think, pretty much is a tour of the no controls capabilities. So despite being a no control, as you can see, there is a lot of control. What we should do is get some gear on the table and do some bloody tunes. Okay, so now we have more toys on the table and our cheery rack boot with a load of modules, lots of drum modules, including Basimilus Iteritas Alter, which we'll mess with from Noise Engineering, and the rings from Mutable Instrument, which is what I've got this hooked up to. So rings is a physical modeling Eurorack module, which responds to analog control voltages, which this puts out, as you will hear. So I'm sending the clock to the gate input so it triggers every single note reliably. And then I'm using the strength outputs, dynamic gate, to go into dampening. And I can use damping as a kind of like, it's a timbral control. And by judicious use of the input attenuator for damping, the damping knob itself, and the knob position of strength, which, as you remember, makes little plucky gates low down and sustained. And I'll give this a little reverb from a Valhalla room. So nice. This would be nice just with a little kick drum under it. And of course, I can program drums because I've got drum modules here, and if I take the gate output from step 1 and just feed it into the gate in, I want them there as well. So I'm going to do some gate mixing using a stack cable. Now I want the Basimilus Iteritas altar to do some kind of like crazy like percussion that will just drone along in the same sort of vein. Nice. Long. Now just a little bit of time and just have a tiny bit of swing. Okay, so let's do some direction messing. Now let's patch this to this. So we're getting ping pong now. Turn up strength. So we get our Basimilus. Wow. Okay, let's do a duet for Basimilus Iteritas altar for noise engineering and no coast. That's the no coast, obviously. And I'll mess around. That sort of stuff. I've had to mess around for quite a while to find it. Excuse me while I clock no coast, thus accessing, no, lock the no coast, thus accessing the random voltage. And you know that random voltage is heading in to something. That's wicked. Yeah. Okay. Scene change. Time for the 808. See how we're using the output of this channel 4 here. The gate flips the direction left and right. So it bounces, it ping-pongs itself at this point. And then using this, it's just such a wonderfully expressive output. I'm directly feeding that into the dynamics of the ukus. And changing the dynamics per step, you just get a totally different sequence. Emphasis. Loads and loads of velocity change. Well, loads of dynamics. Groove, proper groove. And of course as well, this bottom range, that is providing the clock. And it's not steady, so there is swing, which I can vary. Hear that weird slip there. West Coast acid. Yeah. Wicked. joyful. Nice. So nice to be able to play timing like that. Nice. So nice. Creating a lilting cadence. Do you like using the decay time there on the Erbe verb? So why don't you use pressure to control decay on the Erbe verb? Oh yeah. It's wicked. Whoa. Oh, I don't know how to do that before. Nice. Ace.